This is the start of Unit 1, Relations and Functions. Section 1 is on polynomial functions, and you'll find that in Chapter 5 of your textbook. To complete this section, you will be able to develop algebraic and graphical reasoning through the study of relations by representing data using polynomial functions of degree less than or equal to 3 to solve problems. The chapter on polynomials will build on previous knowledge from Math 10C, linear functions, and Math 20-2, quadratics. Polynomials can be seen in a number of real-life situations, such as finding maximum volumes and heights of objects at certain times. You will also learn how to use technology to find the equation of a polynomial function given coordinates. Here's a checklist of requirements to meet the curricular outcomes. Part 1. Exploring the graphs of polynomial functions, notes and practice. Part 2. Characteristics of equations of polynomial functions. Again, with notes and practice from your textbook. Part 3. Modeling data with a line of best fit. And Part 4. Modeling data with a curve of best fit when things just don't line up. Polynomial functions review, which is your formative assessment. And there will be two minor summative assessments, polynomial functions curriculum review and polynomial functions quiz. Let's get started. The first thing that you should do, if you haven't already, is print out this page and have it with you as I'm talking. I'm not going to specifically go through every single one of these. Some of them you should know from previous courses. But I'm going to have just a general discussion about polynomial functions, as well as their characteristics. So, if you haven't got this printed, please pause the video and go and do that now. And then when I start again, you will be able to fill in this table. It is on pages 2, as well as page 3 of your notes. Okay, let's get started. What is a polynomial? In order to have a polynomial function, you probably should know what that is. You first started dealing with polynomials back in grade 9. A polynomial takes the form y equals ax to the n plus a naught a1 x to the n minus 1 plus a2 x to the n minus 2, and so on until you get to an x to the 0. Okay, so basically the word polynomial means many terms. There's a few different categories of polynomials, such as monomials, binomials, and trinomials. Okay? Anything that's greater or has more terms than a trinomial is called a polynomial. A monomial, of course, then, mono meaning one, nomial meaning term. So a monomial has one term. A binomial, bi meaning 2 terms, tri meaning 3 terms. Okay? Now, what is a term? A term is composed of 3 parts. Let's say I gave you a negative 3x to the 4th. Okay, so that would be a monomial, and it represents a single term. The negative 3 is known as the coefficient. Any number multiplied by a variable, so it could be any real number, it could be a radical, negative, positive, okay, is the coefficient. The letter x is known as the variable. And of course, the 4 is the exponent. Okay, as you'll be learning over the next few pages and even into the next lesson, the leading coefficient on a polynomial will tell you certain aspects about the graph. So, for example, if I gave you 5x squared plus 2x, then the one that's the leading coefficient is the 5 because it is attached to the term with the highest degree. Degree is what allows you to tell, is the highest power on the exponent for a polynomial. So because this polynomial has two terms, we take a look and find the degree of each one. The degree of the first term is 2, and the degree of the second term, we can write that as x to the first, even though it's not generally shown. The degree of that is 1. Which of those is higher? That's the 2. Tells us that the degree of this is 2. So what makes this a function? A function occurs when it passes the vertical line test. When for each x, there is only one y. And to pass the vertical line test, I call it the VLT, vertical line test, it means that the vertical line would pass through the graph only once. So no matter where you put a vertical line on the picture, it would only pass through the graph once. So for example, if I drew in a circle, okay, a vertical line would go through that twice. So therefore, a circle is not a function, it is a relation. All polynomials are functions because the graphs only have vertical lines that pass through them once, no matter where you put that vertical line. Now, there's some other points on the graph that you need to know. Those are your x and y intercepts. So if I were to draw this particular graph, okay, you'll notice that where it crosses the x-axis, and in this case that happens 3 times, those are your x-intercepts. Okay. And where the graph touches the y-axis, and in this case it is only once, this is known as your y-intercept. If you look at the graph of the circle, it crosses the x-axis twice, so it has 2 x-intercepts, but it also crosses the y-axis twice, which means it has 2 y-intercepts, and that again is another reason why it is not a function. For that, when x is 0, it should not have 2 y values to be a function. Okay, domain and range. I'm just going to add a page here. Okay, domain is all possible values of x, or the independent variable. Okay, so if you were to, let's say, graph these particular points, then the domain would be 1, 2, 3. Okay, because those are the x values of your points. However, if you were to draw a straight line through all those points that went on forever in both directions, then in that case you would say the domain is just x belongs to the real number system, because all values of x that exist are possible. The same thing is true for range, except of course it is all possible values of y or the dependent variable, because y depends on x. Okay, so again, let's say that this is going up by 2, so that could be 2, 4, and 6 if we were just to draw the dots. Okay, or again, if we were to draw the line straight through, the range would be y belongs to reals. Okay, so that happens when you have discrete data. So discrete is when they're not connected, or when you have continuous data, then you get the x belongs to reals, and that's of course when all points are connected. They're so close together, they just form a straight line. Okay, now, in some of these graphs, you may have to take a look at their end behavior. To know a little bit about end behavior requires you to know about your quadrants. So, back in junior high, you probably learned that we start in the positive x, positive y coordinates. So that would be quadrant 1. And we actually go counterclockwise around the circle to get the rest of them. So the next one is quadrant 2, so that's to the left. Let's make that a 2. Quadrant 3. And quadrant 4 in your bottom right corner. Okay? Alright, so when we're talking about end behavior, we're talking about where the graph starts and where the graph ends. As far as how you read that, you will always read from left to right, just like you would read a sentence. So, for example, if I showed you this graph, okay, on the left side, it's starting in quadrant 3, and on the right side, it's ending in quadrant 4. So, its end behavior then, and I call that EB, is Q3 to Q4. You'll be using end behavior notation from pretty much every chapter on polynomial relations and functions. Okay? Now, this particular graph has one turning point because it goes from increasing to a decreasing function. And that turning point is at the top here. It's a maximum. Okay? However, if you look at my line, it just goes straight on forever. So it has no turning points. Okay? So anything that changes direction has turning points. The more times it changes direction, obviously, the more turning points it has. You'll find out that this is related to its degree, as well as the number of x-intercepts as you go on in this section. Okay, I'm going to go a couple of pages here, so I've got more room. All right. Standard form is standard form of an equation allows you to take a look at some key aspects of the equation. So we have a few standard forms you're going to know. Y equals C, y equals ax plus b, y equals ax squared plus bx plus c, and lastly y equals ax cubed plus bx squared plus cx plus d. Now you don't necessarily have to have a's, b's, and c's for all of those things. So you could have y equals 4x cubed minus 7. And you don't have that bx squared and a cx in that. That's okay. That doesn't change the fact that it's a certain type of polynomial. All right, so from this you can tell leading coefficient, okay, which of course is the value in front of the term with the highest degree. You can also tell the constant term because that is the letter or value, that has no variable. Constant means not changing, whereas variable means changing. So if it has, like in the case of -7, there's no letter afterward, that is a constant term because it's not changing. There is no variable there. Okay? All right, so if I have an equation that just equals a number, okay, then that would just be a constant function. Okay, and if you take a look on the next page, I've provided graphs of 4 different functions that you're going to have to know. So if you take a look at the graph of the constant function, it produces a nice horizontal line. Okay. The next equation, y equals ax plus b, is the standard form of a linear function, which you should be familiar with from Math 10C. Okay, we know that linear functions can also be written in the form y minus y1 equals m times x minus x1, or ax plus by plus c equals 0. Okay, so what you're going to make sure that you are worried about, though, is just the one in the form of ax plus b. Okay, so we're not going to go back and make you redo all those fun questions from Math 10C. Just have to worry about the ax plus b one. You might often have done it as mx plus b, okay, which is totally cool. It means the same thing. Okay, good. Last year in Math 20-1 or -2, depending on where you came from, you learned a lot about quadratics. So this guy here is the standard form of a quadratic function. Okay, again, if you take a look at the graph of the quadratic, it makes that lovely parabola shape. Parabola, if you like to say it that way instead, okay? All right, so you also may have seen the equation reading y equals a times x minus p all squared plus q, which was known as vertex form. Okay, again, you may see it represented as that, but it certainly is the standard form that you're going to have to use in this case. Okay, all right, and last but not least, we have y equals ax cubed plus bx squared plus cx plus d. Okay, and that is for a cubic function, because if you'll notice, the highest degree here is to the power of 3, which we say is x cubed. Okay, so we call it a cubic function. All right, and if you take a look at the graph of that guy on the next page, okay, it's got a very interesting shape. So in the next few sections, you're going to be taking a look at these guys a lot more in depth. If you would now please pause the video and try to fill in the following chart here with question number 2. See how much you can remember from what you've learned in previous courses. You may need to go through part 2 before you can fill it out fully, and I will provide the answers to your teacher so that you may check them when you are finished. Hope you enjoyed this lesson, and good luck.